2 minutes, but we'll have some people logging on, and they can join in here. It's just about noon here. Thank you everybody for joining us for our Lunch and Learn via webinar as we go about continuing to educate our clients in today's new brave world. This will be one of the first, well, it's not, we did a bunch of webinars years ago, and we've been doing a lot of Zoom meetings lately. This is one of the first live webinars that we're doing, and thank everybody for joining us today. Let's see. Oh, so somebody on the chat there. Again, my name is Steve Mertz. I'm the president of DB Sales and Service. I've been in the manufactured rep industry for over 20-some years now, and dealing with boilers, hydronic, and other mechanical systems during that span, and have a background in mechanical engineering. Started out as an engineer, doing designs at a OEM back more than 20-some years ago, and been working here in California in the manufactured rep and space helping design different mechanical systems over the last 20-some years. And if there is any questions, feel free to ask via chat or let us know how we can help address any of your concerns. With that, we're going to get going. The presentation overview, we're going to be looking at a little bit of DB sales history, and we'll cover that pretty quick. Some of the product lines that we do represent currently, the review of the combustion equation, establishing boiler performance criteria, efficiency considerations, examining the various types of boilers out there on the market, then looking at the Southern California heating load profile, some of the modular boiler designs. And we'll discuss system design as well, primary variable flow versus primary secondary, and look at some different piping diagrams and how to implement those as well. And we'll talk a little bit about system implementation, and then also a little bit about EC motor pumps and some draft systems as well, since that touches a lot on some of the boiler systems that we get involved with as well. DB sales history. DB Sales was founded back in 1978, serving the industrial and HVAC industry in Southern California since then. Our corporate headquarters are located in Garden Grove and have been since 1978. We're actually located in a building here on Marcon Drive, and have been here in this same building since 1985. We're a representative for top quality equipment manufacturers, and we have a stocking warehouse here in our corporate facility in Garden Grove for water heaters, tanks, boilers, valves, parts. We have hundreds of thousands of dollars of equipment, and both whole equipment and parts here in stock, as well as our complete boiler rental division is housed here out of our Garden Grove facility. And the boiler rental division has been growing rapidly over the last number of years, doing a lot more and more boiler rentals and boiler rental projects, as we have one of the largest fleets boiler rentals here in Southern California at this point. Some of the manufacturers that we represent here, Advanced Thermal Hydronics is part of the Mestec family of companies. US Draft does mechanical draft systems. Riello, we're going to be talking about today. They're a European company, but have a US headquarters here in North America as well, and they make boilers and burners. Interworks, we're doing a lot of solar heating and projects with Interworks. Velo, one of the largest pump companies in the world. Caleffi does Hydronic solutions. Ice Air, which does fan coils, heat pumps, and some PTAC type units. Airzone custom air handlers. Johnson does burners, Bach water heaters. Airzone custom air handlers. A Hydrotherm line of boilers. Ampco does stacks and generator exhausts. And, even grease duct, Bryan boilers and Burnham boilers, one of the first boiler manufacturers out there. Ace heaters, which was part of the old Ajax boiler. Telehot does tankless water heaters, and some of the largest tankless water heaters in the world. Advanced AMT, Advanced Mechanical Technologies, doing the booster pumps, and then ADI doing our dampers and movers and precision coils, and MCS does chiller retrofit controls, and they pair well with our handle screw compressors for high efficiency compressor projects and retrofits. We won't be covering all of these products today, but just trying to give you a little bit of an overview of some of the stuff that we do have. And if we can follow up with some of these if anybody has individual questions on them on a later basis. High efficiency boiler systems. Hydronics is the most comfortable and efficient HVAC system ever deployed. It's still one of the most efficient ways to provide heating. To talk about the combustion equation here in Southern California especially, we're really talking about firing natural gas. Really, it's the only thing that South Coast AQMD allows you to do, and for the most part, San Diego. Now, they do allow backup fuel oils or backup propane in certain types of facilities, such as hospitals, prisons, and other things like that. But the majority of our boilers are fired with natural gas here in Southern California. So, to look at the combustion equation, you have CH4, which is methane plus oxygen, giving you H2O, which is water, plus CO2. Some combustion facts. So 1 pound of natural gas fuel burn generates about 2.5 pounds of water. Any excess air above stoichiometric, and stoichiometric is the exact perfect amount of air for combustion air or oxygen for every molecule of fuel. So any excess air above that is wasted fuel. Excess air dilutes the flue gas composition, lowering its temperature and decreasing the efficiency of your overall system. Combustion efficiency, we have sensible heat versus latent heat. So if you have typical stack losses, if you have an 84% efficient boiler, your stack losses are 16%. Of that, 4% are sensible and 12% are latent heat. What is latent? That is basically the heat used to change water vapor that is created during the combustion process, or water that's created during the combustion process into water vapor. So the only way to get anything above 88% efficient in a gas-fired boiler is to condense, which means you need to recover that latent heat. And that means you need to go through a phase change where that water vapor that's created during the combustion process turns back into water. That's where the term condensing boiler comes from. So any time you have a boiler efficiency over 88%, the only way to get there is to condense that water vapor that was created during the combustion process and recover that latent heat and turn that back into water that then leaves the boiler in the form of condensate. Then next we talk about burner controls. You have on-off burner controls, high-low, which are kind of a stage firing or step firing, and then modulating type controls. And temperature control will depend on the flow and volume of water in the boiler. Those are all important considerations, factors to consider when looking at your different types of boilers. Some indicators of boiler effectiveness. A boiler in its root element is really a heat exchanger. It's exchanging heat from combusted gas into water or steam on the other side of that heat exchanger. Stack temperature is a great indicator of how effective that heat exchanger is working in transferring energy from the combusted gases into the water or steam on the other side of the boiler. So stack temperature is a great thing to monitor if you're looking to want to monitor boiler efficiency and how well that heat exchanger is working. As your heat exchanger gets dirty over time, the stack temperature could creep up, or it could be becoming less efficient over time as well if the heat exchanger gets damaged or anything else. Stack oxygen. A burner in its root element is really a mixing device. It mixes fuel or oxygen to give us a homogeneous mixture that is then combusted and gives us a flame and allows the energy to release from the fuel. But a burner is really a mixing device. And there's a burner on every gas-fired boiler. The stack oxygen indicates how effective that burner is in achieving proper combustion. The higher the amount of stack oxygen, the less efficient that burner is actually operating. Now, we do have other things to fight here in Southern California as well, such as low emissions and ultra low emissions, and sometimes that drives the stack oxygen up as well because we have to lower that flame temperature so we don't get as much prompt NOx or other NOx formations in there, lowering our overall emissions. So we do have a little bit higher stacked oxygen here, but the overall, in general, the higher the stacked oxygen, the less efficient your boiler system is going to be. And you also have boiler radiation losses, boiler standby and cycling losses. Every time the boiler fires up, it has to go through what's called a pre-combustion purge. Then when it's done firing, it has to go through a post-combustion purge, meaning that you're taking room temperature air, running that over the heat exchanger, and sending that out the stack. You actually start to pull heat away from the loop, your hydronic loop, or from your steam system every time you're doing one of those purges. So those cycling losses can add up. And you must really know all parameters to gauge true performance. Some other factors affecting system efficiency, and these are other terms that you'll hear out there: combustion efficiency, part efficiencies, on-off cycling losses, and then primary boiler pump. That could be a parasitic electrical loss. The different types of boilers that are out there. Firetube boilers, water tube boilers. We have cast iron. We have copper tube. There's a number of different boilers out there in the marketplace. First up, we talk about one of the traditional workhorses of the boiler industry, the Firetube boiler. That was rocket science when they decided to call this a Firetube boiler. We represent the Burnham brand of Firetube boilers. They make traditional Scotch Marine type boiler, which has a completely water-cooled furnace, and they do these in low pressure steam, high pressure steam, hot water, and other applications as well. They make both a compact version, as shown there on the right, as well as the traditional Scotch Marine shown on the left. And the Firetube boiler wasn't rocket science when they decided to come up with the name Firetube boiler. The fire actually travels down through the furnace, which in a Firetube boiler is typically water-cooled, down around through the multiple passes and through the tubes. There's some really nice advantages of a Firetube boiler. It's typically a very efficient type of design. Typically has a lot of water volume in that boiler. And in this type of boiler, these tubes are rolled into the header here and rolled into the back header here. So you can actually do tube replacement without needing to do an AS&E code pressure repair or put an R stamp on the boiler. You can simply cut the tubes out, put a new tube, roll it, and beat it into the front tube sheet and the rear tube sheet. It made for a very good boiler design. It was easily repaired in the field and also very efficient. Now there are downsides to Firetube boilers as well. You have a 500 horsepower Firetube boiler, you could have 20 feet long tubes in it. One of the downsides of that is if you have it in a hot water system, you have varying return water temperatures, and a 20 feet long straight tube, you can end up with what's called thermal shock because those tubes are going to expand and contract. Other types of Firetube boilers out there, which are coming out now, are one that we represent from Riello, which is a horizontal stainless steel condensing Firetube boiler. This boiler is above 88% in efficiency, and it's condensing or turning that latent heat back into, recovering that latent heat by turning that water vapor back into water and running it out of the boiler as condensate. This is a very nice product from Riello, and kind of along the evolution there. This is available up to 10 million BTUs, from 1 million all the way up to 10 million. But it's basically the old Firetube boiler, but done a little bit differently and with stainless steel. And it's still a horizontal Firetube type boiler, which is very good. It has a lot of water volume in it, can do primary variable flow type systems, and it's flow independent. There's been a lot of boilers coming out on the market, and there's been a run for Firetube boilers, and people have turned them on there upside down, and a lot of manufacturers have started releasing what's called a vertical condensing Firetube type boiler. There's been a rash of failures in this type of boiler as people have rushed this type of product to market. And one of the downsides with a Firetube boiler in a hydronic system is the water moves very slowly through the Firetube boiler. Now, why is that an issue? When the water slows down, you go water from a 4-inch pipe running at 8 to 10 feet per second into a 32-inch diameter pressure vessel. That water now is running at half a foot per second or less. Well, any air bubbles or any dirt that was in the water now comes out of solution. And if you get any air bubbles below the surface of this crown sheet and you have a burner at the top firing down against that tube sheet, those air bubbles act as a layer of insulation. Well, when there's a layer of insulation below that tube sheet and fire on the other side up here, and the water is not taking away that energy, you get this top tube sheet will deform and crack. One of the downsides of the stainless steel fire tube boilers that are being rushed to market by some of the manufacturers out there is they're not field repairable. If you get a deformation or a crack in the top of this tube sheet in a stainless steel vertical fire tube type boiler, you have to throw the boiler away and start over. You cannot repair it in the field. It doesn't lend itself to that type of depth. So while there are pros to fire tube boilers, as we talked about, having higher efficiency potentially, being able to vary flow, there are some also potential downsides where they don't react as well to thermal shock. And especially when you talk about a vertical fire tube boiler, we've seen massive amounts of failures from different manufacturers that have come out with this type of product, because when that water comes in, it's very slow, and any type of air or dirt falls to the bottom, or air rises to the top, and can create a deformation in the boiler. So you need to be careful when you're looking at some of the boilers. Another type of boiler out there is the water tube boiler. We represent the Bryan boilers. They make what's called a flex tube boiler. Now, the flex tube boiler, a water tube boiler, does not have as much water volume as a fire tube boiler would, and it typically wasn't as efficient. But as you can see, there's bent serpentine tubes within a water tube boiler. And the tubes were also fit into the traditional water tube boiler. The tubes were swage fit into the steam drum or top drum in the hot water and into the lower drum, which made that you could replace each one of these boiler tubes without needing to do a pressure vessel repair. And since this had that bent serpentine tubes in it, it was very good at accommodating thermal shock. So if you sent varying return water temperatures into a water tube boiler, the tubes would simply flex, and that's where the term flex tube came out. George Bryan invented this type of boiler from Bryan Boiler over 100 and some years ago, and it's been used in the industry for a very long time. Other types of flex tube boilers, now Bryan has released their stainless steel flex tube boiler for condensing applications. These boilers can go up to 90+% in efficiency. One of the nice things about a flex tube, this still has quite a bit of water in it, and you can still do a primary variable flow system. But with this type of boiler, each tube is still fit into this top drum and into the bottom run via a swedge fit. You can actually retube this condensing boiler in the field without needing a pressure vessel arc stamp, and without needing to throw the boiler away and start over. So it's a very interesting type of condensing boiler. It's actually one of the only field repairable condensing boilers where you can actually retube it in the field. And Bryan came out with this boiler. It's available from 1 million up to 6 million BTUs per hour, I believe. Another type of product is the stainless steel water tube. This is more of a low mass type of boiler. The boilers we had looked at before are all considered higher mass. Now this would be considered what's called a low mass boiler. There's nothing wrong with having a low mass boiler. This is another version of a water tube, and it's a stainless steel tube type condensing boiler from Riello. This boiler is a modular type of boiler where a 2 million BTU actually has 4 burners and 4 500,000 BTU per hour modules, giving a number of advantages from redundancy and repairability in the field to this type of boiler. Other types of boilers are copper tube boilers like these from Advanced Thermal Hydronics, part of the Mestec family of companies that we sell. Really a very compact type boiler, very widely used, especially here in Southern California, also known for having a lower first cost, especially compared to some of the stainless steel type of products. Then you have a horizontal copper fin, which has typically stage firing, a vertical copper fin, which has typically been modulating, and then you have a vertical high efficiency condensing unit down there on the right. Now, one of the things about a copper fin tube boiler, all of the heat transfer is really done through a small copper fin. And on the copper fin, you typically only have about 2 to 3 gallons worth of water in a 2 million BTU per hour boiler. So what does that mean? It means you have to have a constant flow of water through the boiler at all times. You can't have only 3 gallons worth of water and 1 to 2 million BTUs worth of burner on the other side, because if you stop the water flow through the boiler, that water would turn into steam relatively quickly. One of the other types of boilers available on the market, and this one's also from Advanced Thermal Hydronics, part of the Mestec family of companies, is a cast iron boiler. And ATH actually did this about 15, 20 years ago. They actually came up with a cast iron condensing boiler. We've had a lot of success with this product over the years and installed hundreds and hundreds of these in California. Cast iron has been used in boilers for over 100 and some years now. It's a very forgiving material, and it provides a very nice product, and you can also do a primary variable flow with a cast iron heat exchanger. It's not quite as efficient as some of the stainless steel products we've showed you from like Riello, but it provides for some very interesting advantages and some nice longevity. Geographical considerations. When we're talking about boilers and heating in Southern California, we're really talking about a boiler that's going to start and stop more in 1 year in the north. The southern U.S. can operate at lower system temperatures because most of our heating here is really building reheat more than actual heating. As a southern region, we really require less comfort heat and much more reheat for humidity control coming off of your air dampers. But it provides a great benefit from using condensing boilers because we can usually use a lot lower operating temperatures. This is our Southern California temperature load profile. This is an average of a 5-year study done by AHR. It shows all the different points, the average outside air temperature here on the left. You can see our design day down here at 39 degrees, but really only operating there about 3 hours per year. And you can see where the majority of the operating hours here are in Southern California. Up here in the, that 50 to 60, those are most of your heating hours when your boiler is going to run. Well, here's the rest of the story. As you can see, about 80% of our runtime, our boiler's runtime, is going to be at 40% or less of your design day BTU load. So you really have to take that into consideration when designing a boiler plant, that more than 80% of the time, you're going to be operating at less than 40% of the overall maximum load of the boiler or your design load. So how do we optimize system performance? We do that through full load performance, which is seldom used, but we really need to make sure that we're optimizing part load performance, especially here in Southern California, which is used all the time. So then we start to consider the benefits of multiple modular boilers. We could probably, if we look at multiple modulating boilers, we can look at better load matching, higher part load efficiency. Typically, a lot of these modular boilers have smaller footprint, built-in redundancy. We can get runtime optimization. And one of the other benefits, especially here in South Coast APMD, which would be the LA and surrounding counties, if we go with a boiler 2 million BTU per hour or under, those boilers are pre-certified with South Coast APMD, and you can avoid permitting and source testing those boilers here in South Coast APMD by going with banks of 2 million BTU per hour boilers. And we've done hundreds of projects where we have banks of 2 million BTU per hour boilers ranging from 2 or 3 all the way up to 10 or even 15 boilers, and avoiding APMD permits by doing that. One of the feature products that really hits on this, and we've really been having a ton of success with, is the Riello Array boiler. It's a high efficiency condensing boiler into the mid-90s for efficiency, and it has multiple modulating heat exchangers or engines in the boiler. One of the nice things about this on the Riello Array, the AR2000 gets a 20-to-1 turn-down ratio and has 4 different modules. Each module is 500,000 BTUs, and each module has a 5-to-1 turn-down. And if you ever have a failure on one of the modules, you can simply pull that module out and replace it. It also is great for spare parts. On every Riello Array boiler of any size, the gas control valve is the same, the blower motor is the same, the igniter is the same, and the burner is the same. So it doesn't matter if you have a campus-wide solution and you want to have multiple boilers of different sizes throughout your campus, all of your spare parts for each boiler are going to be the same. All the heat exchangers are the same, the burners, the igniters, the gas control valves, the air dampers, the fans. It really provides for having a nice amount of spare parts. It really reduces the overall amount of spare parts that's needed to keep your facility running uptime. It's a floor standing condensing boiler with multiple heat engines, Watertube Design, all stainless, 316 stainless steel, has a low water content. And this can be used for natural gas or propane. And one of the nice advantages that a lot of customers like is the uptime. If one of your modules or one of your blower motors ever goes out, you still have 75% uptime. You still have 75% of the capacity of your boiler. So you really can track your load very well. If something does go out, like a blower motor, you still have quite a bit of built-in redundancy on each boiler. So you're not having to send a service tech out in the middle of the night to get that going again. You can probably wait until the morning and do it on straight time. You get a guy out there that can repair that one module and get it going again. And even if you ever did have to replace the module, these modules actually slide out very easily on rollers. Advanced premix, these are ultra low NOx or SCA QMD certified and listed. Maximum working temperature on this is 194 degrees, so it's not going to be applicable for high temperature applications, but it's a condensing boiler. You wouldn't want to run it in high temperature applications. And currently the max working pressure on that's 80 psi. This shows the current Riello Array sizes, a 1 million, 1.5 million, and a 2 million, as well as the 3 and the 4. All the way up to 4 million, even with the dual racks that we have here, that boiler can still go through a 36-inch door, which makes it nice for retrofit applications or replacement applications as well. The smaller units are less than 34 or 33 inches wide. So really good for retrofit applications and trying to get things into existing facilities. Some of the other main benefits, it's complete boiler room in the box, the sole source responsibility, has single point fuel, air, and vent connections, no need for external three-way valves, blending valves, or no need for external pumps. Now there is a small internal pump on each one of these modules that comes mounted and wired in the boiler, but there's no need for any type of external pump or external circulators. One platform, multiple sizes, really lowers your spare parts inventory requirement, doing the common spare parts across every unit for the entire range. Built-in redundancy with superior uptime and reliability. Smaller installed footprint, all the connections are on top of the unit, the stack, the gas, and the water inlet and outlet are on top of the unit, so it really reduces your rear access requirements as well as the side requirements as well. Lowers required footprint, reduces system capital costs, and minimizes system installation costs. Extremely simple to service and maintain. Complete easy access to all components. You can completely isolate each heat exchanger and continuous boiler operation even when individual heat exchangers are removed for service or maintenance. That boiler can still keep on running even if you pull out one of those modules. Something else that's becoming much more prevalent here recently in the last couple of years with some of the decarbonization movements are electric boilers. So we wanted to put this into the slides as well and make sure that everybody knows we do have electric boilers from Bryan. Bryan's been making electric boilers for a long time. And in the last, I've been doing this for over 20 some years now, but in the last 2 years, we've done more electric boilers than they have in the first 20. So it's a sign of the times. We do have electric boilers. The BE series from Bryan is a very compact electric boiler with automatic controls, Inklo sheathed elements. They have 460 volt available, 208, 240, and even 240 single phase. They have output sizes from 98,000 all the way up to 1.28 million BTUs. And they do make this in both hot water and steam modules. But Bryan also makes electric boilers in the larger series, the BH series. These are available 208, 240, 460, or 575. These units are rated anywhere from 60 kW all the way up to 3,000 kW, or it's 196 MBH all the way up to almost 10 million BTUs. And we're seeing some large electric boiler projects these days. These are available in hot water, high temp hot water, steam, both low and high pressure steam. Now to go into a little bit of system design. And we were talking about our boilers earlier. We looked at fire tubes, water tubes, we looked at copper tubes, and this is a primary variable flow system. So if you have a high mass boiler or a boiler with a lot of water in it, typically you can do what's called a primary variable flow system. And you want to do a balanced flow type design so the water is balanced through the flow of each unit. And then you typically have a motorized valve on each one of the boilers, so water is only flowing through the boilers that are firing. And typically on these, we're daisy chaining the boilers together, we're lead lagging these, and then we're controlling this primary valve from the boiler to either open or close that valve based on if the boiler is going to fire or not. Then we have a system pump here, and this drives water throughout the entire system. This is called a primary variable flow system, and this is typically how it's laid out so that the water is balanced through each of the boilers. You want balanced flow, so no boiler is getting more flow than the other. And then also the key, having that modulating or motorized valve either on and off to control the flow of water through that boiler. This is a primary secondary type of system. Now we're talking about our lower mass boilers like our thin tube type units or even some of the like the Riello Array. We really want to look at more about what's called a primary secondary type piping configuration. Now with a primary secondary configuration, you don't have a primary valve on each of the boilers, but again, we still have our reverse return type piping so that you get balanced flow through each one of the boilers. And now we also have the individual circulator on each one of the boilers. Now this circulator would typically be controlled from the boiler with a primary, with a pump delay relay, controlling this pump on and off and leaving that pump run for 10 to 15 minutes after the boiler stopped firing to carry away any residual heat. Now one of the primary things that you need to take into consideration when looking at a primary secondary type piping is your closely spaced piping tees, and make sure that these are actually spaced very close to create what's called a low loss header or an area of very low pressure loss so that the flow can go in either direction in this piping here. And this is how a proper primary secondary type configuration is. You have your primary boiler pumps and then your secondary distribution pumps sending water out into the system. And with these two closely spaced tees, that provides the hydraulic separation so that the flow from these pumps don't affect the flow from these pumps. And vice versa, when this pump is on variable speed drive ramping up and down, it's not affecting the flow through each one of these boilers or those pumps. Another way to do primary secondary pump piping is with a hydraulic separator. This is one that we sell from Caleffi and that we've used on numerous projects. It's an all-in-one type device. It basically has 4 ports, which eliminates the need for your closely spaced tees in your primary and secondary configuration. You have an automatic air vent and a built-in air separator with a mesh inside, and then a sediment drain or dirt drain on the bottom of the unit. To and from, you have your piping from the boiler back to the boiler loop, from your system and back out to the system. But this provides a very low loss head or low loss pressure area so that the water can flow in either direction, depending on if the water is flowing higher on the boiler side, then the water can flow this way. If the water flow through your system is higher, then the water can flow this way. And that you get a constant flow of water and that proper hydraulic separation. This is showing another piping diagram showing that primary secondary type piping configuration with separate air separator, separate closely spaced tees, and then even a dirt separator. This is showing the hydro separator taking the place of those 3 components because of built-in air separator, built-in dirt separator, and it is a hydraulic separator, so it has your 4 ports, 2 for your primary boiler loop and 2 for your distribution loop, really simplifying your system and your primary secondary piping. It also better protects the boiler because it's oftentimes your air and dirt separator are on your distribution loop and not on your boiler loop. This protects both the boiler loop and the distribution loop. When should you use one of these? Anytime you're installing a low mass or a high efficiency type boiler, especially one that's going to be susceptible to air and dirt in the system. One of the other things that's now available in our hydraulic separators, or also available in our air and dirt separators, is a magnetic separator option. This is basically adding a permanent fixed magnet inside of your hydraulic separator, inside your air and dirt separator, to make sure that we're pulling out any ferrous material from the circulation through that water that's circulating through your line. Now, this becomes extremely important, especially when we're talking about high efficiency boilers. And when I show you the high efficiency pumps on the next slide, you're going to see why it becomes even more important for those as well, to make sure that we're doing magnetic separation in these systems to really pull out all that ferrous material. And it's really not a very big price add. It's a fairly inexpensive, usually less than $1,000 price add into one of our air and dirt separators or one of our hydraulic separators. Now this is electronically commutated motors that we also sell, or EC motors, pumps, I should say, not just the motors. We sell it as part of a pumping package. On the left here, we have our standard asynchronous motor. Asynchronous motor has a motor winding. And the way an asynchronous motor works, it has this motor winding here, and it basically runs an electrical charge through that motor winding, which creates a magnetic field. That magnetic field then turns the stator and then turns the motor shaft, and in a pump application, turns the motor, or rotates the pump. Over here on the right, we have an electronically commutated motor with, you can see your permanent fixed magnets, both the north and south. And the way an electronically commutated motor works is it reverses the polarity of those internal permanent fixed magnets between north and south to turn that stator, which turns the shaft, which spins our impeller on our pump and pushes water out into the system. And that's basically the difference between an asynchronous motor and the way an electronically commutated motor works. One of the big advantages of electronic commutated motors come when you're talking about motor slip. In an asynchronous type motor, you're constantly chasing a rotating magnetic field, which has a much greater slip than an electronically commutated motor. That slip is even greater enhanced, or becomes greater and greater on a VFD controlled pump, as the VFD turns speed down by turning hertz, lowering the hertz on that drive. That slip gets larger and larger and larger, thus reducing your part load motor efficiency. Well, you do have slip, a little bit of slip on an electronically commutated motor, but not very much. And as you turn that pump motor down, the slip does not get greater. It really maintains its efficiency during the entire turn down range of that motor or of that EC motor pump. Now, when we're talking about magnetic separation, it becomes extremely important when we want to look at implementing an electronically commutated motor. Why? Well, there's permanent fixed magnets inside of this motor. And when you have permanent fixed magnets inside of the motor, if you don't pull out ferrous material before it gets into the pump itself is going to start pulling all that ferrous material out from your hydronic loop. And it doesn't matter whether it's a chilled water system that we're doing, or hydronic heating, or condenser water loop, whatever it is, this type of pump will pull magnetic particles. Wheeler was the first company to put electronically commutated motors in the pumps more than 20 years ago. We at DB Sales have been selling this for over 10 years. We have a lot of field experience with electronically commutated motors being used in pumping applications. And we've seen a lot of systems that may have air and dirt separators on them, but they're not pulling out ferrous material because they didn't have any type of magnetic separation. Well, that ferrous material ends up in this pump, and it's not good for the pump. And we can, you can destroy a pump, you can make it so it needs to be cleaned more often. There's a lot of ramifications for doing that. So when you are looking at some of these high efficiency boilers, and especially if you're looking at electronically commutated motor pumps, you really need to be looking at, in my opinion, magnetic separation if you do have any type of ferrous material in those lines. This is the Stratos Giga. I need to actually update this slide still. But the Stratos Giga is a vertical inline electronically commutated motor from Riello. This pump goes all the way out to about 500 GPM now. They have the larger sizes, and they go from smaller all the way up to about 500 GPM. Riello also makes their newer pump, which is the Stratos Maxo, which is a 120 volt single phase, basically inline circulator that's available with an electronically commutated pump too. Those go to about 1.5 horsepower. The Stratos Giga, those go up to about 10 horsepower. And as I said, about 500 GPM or so. And those are available for heating hot water systems, for chilled water systems, closed circuit coolers, and other applications as well. When we're talking about gas-fired appliances, one of the other things that you have to do with it is you have to vent it. One of the other products that we represent and we have great expertise with is boiler venting. Whether that's the AMCO stack, the heat fab stack material, we can help design that stack. Or if it needs to be multiple units into a common, we have the US draft, mechanical draft systems, and we can help you design a common venting system where you can vent multiple modulating boilers into a common and use a fan system either at the end or in line. We have multiple configurations for this. And then we would control the boiler flue by putting a pressure transducer into the end run of the boiler flue and controlling either on a VFD or on an electronically commutated motor fan, and varying the speed of that fan to maintain a constant pressure in our stack, thus optimizing our boiler efficiency and creating opportunities for us to be able to vent multiple modulating appliances into a common stack without having to worry about the adverse effects of one boiler firing and affecting the draft in the other appliance. There's also a lot of code things that you can get away with running stacks very long, not having to terminate above parapets. There's other potential code issues that we can get around by using a mechanical draft system. This one showed here is a termination type fan assembly. We have 10 models available on these up to 19,000 CFM. Temperatures can go up to 1,000 CFM with continuous run. Super efficient electronically commutated motors or induction motors used on these fans as well. And they're available in 430 stainless steel or 316L, depending on the application. They also make a Trueline fan system designed that can be installed in vents without an offset. It's kind of a unique product. They have 11 models here with capacities up to 9,000 CFM. Again, continuous operation on these up to 575 degrees. And it's available in 430 or 316, depending if we're doing condensing or non-condensing applications. And we also have the Trueline 90-degree, which is basically a mechanical draft system that allows you to do a 90-degree elbow. The fan basically goes in place of a 90-degree elbow in the stack. So we do have quite a bit of options available when we're talking about our boiler system design and venting design that we can use these, whether it's the termination fan, the inline fan, or the 90-degree fan, to help you with the application that you're looking to do. We also have overdraft dampers from US Draft, provide multiple blade, opposed blade dampers. This can help with overdraft type conditions. I would make these for individual boilers or for common stacks. And this would have, especially if you have very tall stacks, you might have a condition where you have a hot stack that's very tall, you're creating a lot of natural draft. There might be a condition where you're potentially overdrafting your boiler and pulling the flame off the burner down into the heat exchanger, and you want to prevent that. So you might need an overdraft damper in those types of systems, especially where you have very tall stacks. Another type of system that we offer when we're talking about the boilers is a combustion air makeup system. This is another type of fan system from US Draft. We have our multiple modulating boilers, and we don't have enough room for louvers, or we don't want to duct each boiler outside individually. We can put ducting into a single fan and bring combustion air in through this system and have a pressure sensor in the room and a pressure sensor outside, and then modulate this fan on a variable frequency drive. Again, this is interlocked with each of the appliances, so the appliances can't fire if there's not sufficient combustion air within the room. And you can get away with not needing louvers, or not next to an outside wall that communicates directly with outside. This may be an easier solution for you to consider. We also offer packaged hydronic systems from DB Sales. This shows some of the types of skids that we can put together with the pumps, air separators, expansion tanks, top feeders, multiple boilers, boiler isolation valves. You can do primary, secondary type systems. And that just shows some of the different types of package systems. And then we have our complete rental division as well. We really do have some of the most expertise on boiler systems around in California. And any questions, comments? That was really it for our presentation today. Thank you for being here. And then we'll open it up to any questions anybody has, if anybody does still have some questions or comments.
Yeah, I got a question on the condensing array boilers.
Yes, Ken.
Can they be field retrofitted to add another section or two to it in the future if need be?
I haven't had that question before, Ken, and I would need to ask with the factory, to be honest. I don't know off the top of my head. Nobody's ever asked me that, and I hadn't looked into that before. But
I guess the follow-up question, would that be less expensive than just providing a new or a few more new sections next to it?
My guess is it's probably going to be more cost-effective to just add another unit right next to it, rather than trying to buy a unit with oversized, because you'd probably have to buy a unit with the oversized cabinet and then you'd have to have the sections in there that we could put the engines in the future. My guess is it would probably be simpler and cleaner to just have room for multiple units and then put a whole new unit in next to it if you ever wanted to do that expansion. But again, I said I could research that with the factory, and it's something that nobody's asked before, to me at least, and see if it's possible to do that in the field. Then we'd have to get into seeing whether it's more cost effective to do that or not.
Right. Okay, thank you.
Okay. Anyone else? Okay. Well, thank you everybody for coming on. And myself, Steve Mertz, and the president over at TB Sales. You can always get a hold of me, or Austin Buckles is our sales manager. He's available as well. We have our, as well as our local sales engineers throughout the region. We have multiple local sales engineers that can help you as well. Feel free to reach out to any of us and let us know how we can help you on any of your upcoming projects, or if you have questions like Ken did here for specialty type things, we'll certainly research that and get back to you. Thank you everybody for coming out today, and stay safe out there, and be well.